Yesterday, our exploration, what was it that we discovered?
Continuous and discontinuous.
Alright, we discovered what makes a function continuous and what makes a function discontinuous. So today we mainly want to talk about continuity, and eventually we're going to prove whether or not a function is continuous or discontinuous at a point. So let's look at number one. Number one asks us to do four things. It asks us to find three limits, and then it asks us to discuss the continuity of the function. So let's start with the limits. And part A says limit as x approaches c from the right. So c is 4. What's my limit as we approach 4 from the right? What is it? 3. What's my limit as I approach 4 from the left? 3. And then what's my limit as we approach 4? It is also 3. So all three of them are 3 on number 1. Now, what can you say about the continuity of the function at 4? It is continuous. Now, let's talk about the three things we ended with yesterday. Three things have to happen for a function to be continuous at a point. There has to be a function value. There has to be a limit. They both have to equal each other. Okay, they have to equal each other. So, at 4, we have a limit, we have a function value, and they equal each other, so we would say that we are continuous at 4. Alright, let's move over to 3. Limit from the right on 3. On 3. Limit from the right.
I was looking at 2, my bad.
0. Limit from the left.
0.
And the limit. 0. So all my limits are the same. Am I continuous at that point?
No.
Why not?
The function value is 1.
There's a point there. I've got a point right there.
Function value is 1.
The function value
Function value does not equal the limit. That's what I want to hear. Okay? That's why I would not be continuous on that problem. Let's look at 5. Limit from the right.
-3.
-3. Limit from the left. 3. The limit
Does not exist.
does not exist. So what can I say about my continuity? It's discontinuous because the limit does not exist. Okay? Now, there are multiple reasons why that limit does not exist. Okay? Obviously, the limit doesn't equal the function value. But I only need one thing to be said to make it not continuous. So do not go overboard on trying to explain why it's not continuous. Just give me one reason why it's not continuous and move on. Alright, so let's look at 27. 27, this one says discuss the continuity of each function. So this could be the function is always continuous, the function is continuous except for. So if you tell me it's not continuous, you need to give me a reason why it's not continuous at a specific spot. So talk to me about 27.
It's not continuous.
It's not continuous where? You have to be specific.
Add 2 and -2.
At 2, at x equals 2 and -2. What would my reasoning be? Asymptote is not acceptable reason. Jump is not acceptable reason.
Not
It
a
is a
limit.
function.
No limit.
No limit.
The limit does not exist at x equals 2 and -2. That is acceptable. There are only two things that are acceptable reasons for a function to be non-continuous. What are they?
Limit.
Well, actually, there's three things.
Limit does not exist.
Limit does not exist.
Function value does not.
Function value does not exist. The limit does not equal the function value. Those are the three reasons we can say something is not continuous. All right, 29 up at the top.
Whoa.
What can you say about that one? Not continuous where? -1, 0, 1. Why? The limit does not exist. That's my reasoning. All right, next page. 77. 77 says, what does it say? Describe the intervals on which the function is continuous. So on 77, where is the function continuous? Everywhere. Now, how do I describe that interval?
Infinity to negative, with negative infinity to infinity.
Negative infinity to infinity. So I would say on the interval, negative infinity to infinity. All right. What about 79?
Negative infinity to not negative 2, negative infinity to negative 2.
Negative infinity to negative 2. What do I need to put on that negative 2? A parenthesis.
Negative 2,
Negative 2 to 2,
and then 2 to infinity.
and then 2 to infinity. I am continuous on all of those intervals. Okay, now on the first day we talked about how the AP test was set up. So who can give me something about how the AP test is set up? All right, there's 45 multiple choice. How are those broken up?
Calculator.
All right, how many non-calculator?
19.
There are 28 no calculator. How many calculators? There are 17. So 28 no calculator, 17 calculator. Then what was the other part of the test? Free response. How many free response are there? There are 6. Okay. There are calculator and non-calculator. How many calculator problems? 2 calculator problems, which means there are 4 non-calculator problems. Now, what you need to know about free response is the calculator problems are always first. So when we're looking at free response questions throughout the year, if it's an AB1 or an AB2 problem, you know that you're doing what?
Calculator.
Using a calculator. If it's a 3, 4, 5, or 6, you know that it is a non-calculator. So, if we look at this one right here, it says let g be the function defined by g of x equals that piecewise function. And this should be, this is an error. We figured it out today. This right here should be x equals negative 3 instead of 3. Because it makes no sense for it to be 3. All right, it says use the definition, or it wants us to know, is it continuous at negative 3? Use the definition to explain our answer. So that means we want to use that 3-step process to determine whether or not this is continuous or not at negative 3. So what do I want to do to get started? And again, this is just one part of a free response question. What do I want to do to get started? If I'm going to prove that this is continuous or not. What?
Plug it in.
What do you mean by plugging in?
Like
What is it I'm finding?
the Y.
So the function value? You want to find the function value. All right. So we'll say part 1 is finding the function value. We want to find g of negative 3. Which one do I plug into to get g of negative 3? The top? What do I get when I plug it in? Should get 4. Plug in negative 3, that gives me 9. 25 minus 9 is 16. The square root of 16 gives me 4. So we've got 1 of 3 down. The function value is this. Now what do I want to do? Find the limit. Now, since it's a piecewise function, what do I have to do to find my limit? All right, so what is it exactly that I'm finding?
To see where it's coming from. So that
Right, there you go. I need the limit from the left, and I need the limit from the right. So we are approaching negative 3 from the left of g of x, and we need to approach negative 3 from the right of g of x. All right, so what do I plug into if I want to approach negative 3 from the left? Top or bottom? Which one? Top. Now, it's a good idea to show them where you're plugging in so they know which part you're plugging into. So I can go ahead and show that, and then show that this is equal to 4. Okay, negative 3 from the right, where do I plug in? The bottom. So I want to show them that I'm plugging in negative 3 into the bottom, which gives me 4. So, since my limit from the left and my limit from the right are both 4, what does that mean? You're gonna hit up. You're gonna hit up.
Oh,
I have to say
limit
something.
4.
The limit's 4. That's what I'm looking for. Alright, so there is 2 parts of the 3-part step, or the 3-part process. What does the third part need to be?
See,
Alright, I have to show that they're the same. So I want to show g of -3 equals the limit as x approaches -3 of g of x. Now I need to end with a statement. What should my statement be? It is continuous. Because right now I've shown what's necessary to prove it, but I haven't said what I've done. So here's what we do. And third hour didn't know what this symbol meant. Do you guys know what a 3 dots in a triangle means? What? It stands for therefore. So anytime you want to say therefore, you can do that, the 3-dot triangle, and that will replace therefore. So we're going to say therefore, g of x is continuous at x equals -3. That answers the question. That's something that you got to get used to in calc. Is you can do all the work and all your work can be correct, but if you didn't answer the question that they asked, then you're not going to get full credit for it. Okay? This problem happens to be worth 2 points, and you can get one of the 2 points without saying that final thing. But if you want full credit, you have to answer the question, because the question says, is G continuous? And if you don't write this statement right here, did you say that G was continuous? No. You've given me the information that helps me decide, but you haven't told me. So I need, therefore, G of x is continuous at x equals -3. And this would be, there's 9 points for each free response question. This part of the problem is worth 2 points. I looked it up. It said you get 1 point. You get 1 point for considering the left and right limits, and then you get the second point for everything else plus your final statement.
So you don't have to explain because you just showed your work.
Right. The work is the explanation. I just got to finish it up with a final thought. Tell them what it is I just found. All right, this one says 2011 B, AB2. So since it's AB2, is that a calculator or non-calculator? Calculator, so have your calculator handy. So a 12,000 liter tank of water is filled to capacity. At time t equals 0, water begins to drain out of the tank at a rate modeled by R of t, measured in liters per hour, where R is given by the piecewise defined function. So R of t is a rate. It wants to know, is R continuous at t equals 5? Alright, so help me out here. What do I need to do? I don't need to do that. If I'm going to prove whether or not something is continuous or not continuous, there are certain steps I have to do every time.
Find the function.
Find the function value. So first thing I want to do is find R of 5. Now, which one am I plugging into to get R of 5?
Top.
The top one. Now, I'm going to show you something. I do not have to get an actual number. Once you plug in, you can leave that as your answer. So if I wanted to, I could stop right there, and that would be enough to show the function value. Okay? But in this case, I need to go ahead and work it out because I've got to see whether or not these two things are equal to each other, and I can't tell that without working it out. So with your calculator, go ahead and tell me what that would be. I want to say 375. So there's part 1. So the function value does exist. So what do I have to check on part 2? I need to find the limits. And since it's a piecewise function, what do I have to do? I need to find both directions. So limit, and my variable here is t, so instead of x, I'm going to say as t approaches 5 from the left of r of t, which one do I want to plug 5 into if I'm doing it from the left?
The top
The top one. So that's going to be, again, you want to show them that you know which one you're plugging it into. So that would be 5 plus 8, or sorry, 5 plus 3. And I get 375 out of it because I just figured that out in one go. Then I need the limit from the right. Where do I plug in to get the limit from the right? The bottom. So that would be 1,000 e to the negative 0.2 times 5. And somebody punch that in. Give that to me. I want to say it's 367 something. 367. 879.
Yes.
Okay. So what does that tell me?
Oh, there's not.
Right. I need to show that the limit does not exist, and then I need my therefore statement. So I do my 3 dots, and what's my therefore statement going to say?
R is discontinuous.
RT is not continuous at t equals 5. Questions on that?